Hello and welcome to Minikun Tutorials. In today's tutorial, we're going to look at how to change the number of decimal places in a data frame column in R or RStudio. So I repeat, in a data frame column, okay, which means after reading your CSV file, your TXT file, whichever file that you read into R in the form of a data frame, or even if you have created your own data frame, okay, or your own data set in R, or even if it's a data set that is a pre-existing data set in R that you've just loaded, and you are interested in changing, let's say, decimal places within a particular column of your data frame or your data set, this video will help you do that. Okay, so it's very simple. And please bear with me that there's a little bit of noise in the background, so please just bear with me. I'm so sorry about that. And then our tutorial is going to cover three major parts. In the first part, we're going to look at how to just round or change the number of decimal places of values within a particular column. For instance, let me read this particular data set into R and show you what I'm talking about. So if I should read this into R, it's actually a CSV file that I have on my desktop named my data, and I'm going to save it in an object called data. If you have difficulties in reading data set into R, please look in my channel and you find several videos on how to read data set into R. So the data is well read, and if I should print it to show you, you see what it is. Okay, so let's assume it's a data set of 14 patients. So we have the patient ID, the gender, the age, the weight, body weight, diagnosis status, and then the year of birth, for instance, or the year of diagnosis, whichever. Now, assuming we are interested in rounding the weight of patients to 2 decimal places, how do we do that? It's very simple. The question that you have to ask yourself is, and we can even round the age of the weight of these patients to the nearest whole number. We can do that. So we look at both. Okay, so if we are interested in rounding the weight of these patients into 2 decimal places, how do we do that? It's very simple. The first question you have to ask yourself is, do you want to create a new variable, or you simply want to maintain the existing variable but with the changes being done? So first of all, we do it with a new variable, with the existing variable. Okay, so we just simply round these values to 2 decimal places. And then in the second example, I'll do it to the nearest whole number, and then we create a new variable. So let's start. We are interested in rounding weight, right? So we will use the formula format, okay? But to do that, we'll say data first of all, then we use the $sign to select the variable in question. So we are going to round which variable? Weight. Please spell it the way it is, weight with capital W in my case. So I'll put weight, data $weight here is equal to what? Then I'll use round, first of all, format into brackets. We are going to round to how many, what are we rounding? We are rounding the variable or the column data $sign weight. If I were interested in creating a new variable, then I would have kept the variable name here instead of maintaining the initial variable. But I want to put I want the changes to be applied to the initial variable, so I haven't changed the name. And now I have to indicate I want to round it to how many digits. So we are saying first of all we will try with 2 digits. So I'll say digits. We want to round it to 2 decimal places. So in that case, we say digits is equal to 2. We close the bracket, then we put comma and specify the number of decimal places. So to specify the number of decimal places, say n small is equal to, then you say, let's say 2. Remember, the number of digits after the decimal point is not the same as the number of decimal places. Though I'm saying this for a reason. For instance, if we have, let's say, if you want to keep 2 digits after the decimal point, so it will be what? 0.56. This one will be 0.57, 20.57. This one will be what? Because this up to 5, so this becomes 7. This one will be 27.98 in that order. Sorry. However, if you want to keep it in 4 decimal places, we can choose to round it to 2 digits after the decimal point. However, since we want 4 decimal places, then we say n small will be equal to 4. So this one will become 0.5700, 0.9800, or whatever. So just to tell you that the number of decimal places is, or the number of digits after the decimal point does not necessarily mean the number of decimal places. So we can say n small is equal to 2 here, then we are good to go. Simply close the bracket, and then if I should run this, the changes will be applied. I don't know, I think I'm missing something. That's why R gave us the error. Okay, R is saying that our variable weight, unfortunately, is not numeric. Oh, sorry. I think I misspelled weight somewhere along the line. Weight here, I'm sorry, weight. This is how it's supposed to be, weight. I'm so sorry about that. I misspelled it. Okay, now it's perfect. And then if I should print the data set again, print the brackets data, you would notice that the weight of our patients is now in 2 decimal places. Okay, but before we proceed, anytime you read data set into R, always use the str command or code to know whether R has been able to import your data, has been able to recognize the true nature of your variables. So if you say str into brackets data here, if I should run it, you see that R is telling me that weight is a character, which is a lie. Weight is actually an integer or numeric. These are numeric values and not characters. It's not a string. Okay, so how do we change this? So to change weight to numeric, we simply have to say what? We simply have to say, let's say the data $weight is equal to as.numeric, which means consider as numeric, as.numeric into brackets data $weight. Let's do that, and then we proceed with the other steps. Now this is done, no error given. If I should say str into brackets my data again, now you realize that weight has been converted to numeric. Now in the second thing that we'll be doing is that we will actually try to round the weights of the patients to the nearest whole number. So how do we do that? Then we save the results in a new variable. We create a new variable for that. So let me simply copy this code and I'll paste it here. And then the new variable that we'll be creating, we call it weight underscore, let's say, sorry, underscore round, which means we have rounded it to the nearest whole number, weight underscore round. And then we are rounding weight to the nearest whole number. It's just a new variable that I'm creating. Okay, that's why I changed the name of the initial variable. And now remember we said we have to round it to the nearest whole number, so we have to indicate that digits after the decimal point is 0. There are 0 digits and there are no decimal places, so we put here to 0. Now if I should run this, let's see what happens. No error given, perfect. Let's print our data set, and you would realize that a new variable has been created called weight rounded, okay, or weight round, whatever. And then the weight has been rounded to the nearest whole number. If I had wanted this to be applied to the initial variable, then I would have just maintained here data $weight instead of put in a new variable name. In the case where we want to round it to the nearest whole number, but we want, sorry, I'm so sorry. In the case where we want to round it to the nearest whole number, but we want to have some decimals, so it will be, let's say, 21.00, then it's very simple. Let's copy this and paste it again. And in that case, I'll simply say number of decimal places should be equal to 2. So R will actually round our value to the nearest whole number. That's why we kept digits to be equal to 0. However, we are saying that it should indicate 2 zeros, 2 decimal places, so it will be 0.00. So I just kept n small is equal to 2. If I want 0.003 of them, then I have to put n small is equal to 3. So if I should run this and then print our data set again, print to brackets data, you see what I'm saying? So we have weight rounded to the nearest whole number, but in 2 decimal places, so it has kept 0.00. Now the next thing that we'll look at is in the case where we want to add, let's say, 0.00 here to a variable that is already in, I think we've already done that. I mean, with the weight we've already done that, but let's assume we have h here and I want h to be presented as 10.00, 11.00. How do we do that? Let me simply copy this code here. So if you have your variable in whole numbers, so let me just paste this here. So the variable in question is now h. If we want to create a new variable, then I have to say h something or whatever, but I just want the changes to be applied to directly to the variable, so I just put h here, and then over here will be h. Okay, n small is equal to 2, meaning we will have h here will now be what? Remember, h, there were no digits, there was not a decimal, so there were no digits after any decimal point. That's why I kept digits is equal to 0. Okay, but we want 2 decimal places, so I will put, that's why I kept n small is equal to 2, so I will put 10.00. That's what I did here. So if I should run this, no, sorry, it's this one. If I should run this, now if I should print h, print our data set again, so you notice that h is now 10.00 in that order. Let's move on to the next thing. The next thing will be how we can actually simplify. I'm so sorry. I'm so sorry. In fact, this is a French script, so I was doing the English version, but I actually forgot to change some of the things to English. Okay, so this note that I've written here, the example 2, I wanted to say, for instance, I wanted to say, if I didn't change it, I'm so sorry about that. If I wanted to say, if the column contains whole numbers. I recorded the French version of the video, and then when I move on to the English version, I forgot to, probably I was tired to edit the whole script. So if the column contains whole numbers, like h here, it contained whole numbers, as you can see, and then we've decided to add 0.00. So how to add this, how to add extra zeros, how to add, or how to add decimals. I wouldn't say zeros, into bracket zeros. That's what we've done here. Now the last thing that we will look at is how to simplify, I'm sorry, this was also in French, how to simplify large figures. Okay, large figures, simplify large figures in a column. So for this example, I will explain. Let me read this particular data set. It's another data set that is called FX19. So I'll read it into R and I'll show you what I mean. So let's read this data. Now if I should say print into brackets data, just to show you the data set, it's actually very voluminous, so R might not show me everything. As you can see, the data is too large. So if I want to show just the first 10 persons, then I have to use head into brackets data, then I put comma and specify that n is equal to 10, so that it can show us just the first 10. Okay, here they are. We have the first 10 people here, as you can see. And supposing that for the variable value here, okay, so we realize that value is very large, okay, or we can even pick the variable cumulative. So cumulative, why has R presented it as 1.04 exponential plus 10? This simply means 1.04 times 10 to the power 8. Sorry. Okay, so why has R written it as 1.04 times 10 exponent 8? What's the meaning of that? It means this is supposed to be 104, and then I think 104, this is still the same value, I guess. If you should round this to, let's count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so whatever. Now this is just another presentation of this, just the same value but presented in a different manner, or these are even different figures. As you can see, this is different. Okay, this is a cumulative. So we have this plus this gives us this, plus this gives us this. That's not, we don't have any interest in any of this. Okay, but the purpose of this is just to tell you that if you have very large figures like this, sometimes you don't want the cumulative to be presented this much big. You don't want to have these exponents. You just want your data set to be much simpler. Or let's even pick value. We don't want to have 104 million. It's hard to read, right? So since it's hard to read such large values, we can decide to create a column that we just say value underscore million, and then we just put 104. When we see 104, it means 104 million, right? So how do we do that? It's very simple. First of all, use str command to know the nature of your data set. Str into brackets data, and then we realize that the variable value, for instance, if we are interested in converting value, is actually an integer, right? So since it's an integer, and then we want to convert it into whatever, right? So it's an integer. Now I said we want to convert it. Since it's an integer, it's fine. It's actually an integer. These are numeric values. So if we are interested in creating a new column that we'll call, let's say, value underscore million, then we can do that. How do we do that? Let's just say, for instance, we'll have, or let's pick the totals. Let's pick the cumulative, because the cumulative is the one that is not presentable, because that one is this exponent, this is hard to read. This, we want it to be in millions. We want just to have simple figures, so we can decide to divide all these values by a million so that it will be easier to read. So this one will be 104 million, this one will be, I don't know what, 200 million, in that order. So how do we do that? We simply have to say, for instance, let's look at cumulative. Is it also an integer? Cumulative is also numeric. Perfect. So how do we do that? We simply say data $, let's say cumulative. You write it, the name of your variable, the way it is, cumulative here, okay, is equal to, then we say format, okay, format into brackets round into brackets data. So let's assume if we want to create a new variable, then we'll have to call this new variable cumulative underscore million, okay, is equal to format into brackets round data $sign cumulative. We put comma, we specify the number of digits, then we say digits is equal to 0 because we just want to put it in whole numbers, but we just name the column values in million or cumulative in million. So digits will be 0, and then we specify the number of decimal places. We don't want any decimal places, we just want the figures to be readable. So we say n small is also equal to 0, and now we have to close our brackets. So we close these brackets, which is for format here. Just one bracket is okay. Yeah, let's run this and see what happens. What is this telling me? It's telling me that blah 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 object type closure. I don't know what it's saying. I know what I missed out something. But data $sign cumulative underscore million is equal to format in brackets round data $sign cumulative digits is equal to 0. I'm sorry, I'm so sorry. So we have to divide this by a million. I forgot to do the division. So we divide this, okay, by a million. 1 2 3 4 5 6. I forgot to do the division. So let me run this and see what happens. It's still giving me an error. I don't know where I'm getting things wrong. I'm so sorry. Data, I wrote data as a small sign, small d instead of capital D. Okay, perfect. I think now we are good to go. Okay, perfect. Now let's run our code and see what happens. Let's print the data once again. Since the data is too much, we just show the first 10, head into brackets data comma n is equal to 10. Now we have a new variable which is created, okay, and it's cumulative underscore million. So we have 104, 200, 262 million, this 104 million, 200 million, 262 million, in that order. Thank you so much for watching, and please subscribe. Bye.